Geometric series should be very similar to the last lesson in purpose, but we are using geometric instead of arithmetic series. And then some new vocabulary would be converging and diverging. So if something converges, it moves towards a point. If it's diverging, it's moving away from a point. So when we see geometric series that are infinite, kind of going on forever, does their sum converge to a specific number, or does it diverge and you can't find what the sum is? So there's some formulas again under these key concepts that we're going to be using. So for geometric series, there's two different formulas. There's one if it's finite, so I'm just trying to find the sum from here to here. And then there's another formula we'll use if it's infinite, if it's continuous. So to find the sum of the finite geometric series, first again, you need to know your explicit formula. That's what goes into your numerator. So you need to write that first. And we should be proficient with that from the previous lessons. So we have our terms here, 3, 6, 12, 24. We need to find, we know what A1 is, it's 3. We need to find the common ratio. You do that again by dividing a term by the number in front of it. Okay, and then now I can write my formula. Okay, so a to the n is going to be 3 times 2 to the n minus 1. And let's see what else is missing here. We want to find what term number this is so that we know what our limits are. So this is the first term to which term number is this? So we will substitute the 3072 to solve for n. So we're going to divide by 3 first. And then this step is a little bit tricky. They say they're kind of supposed to know that 2 to the 10 is 1024. So they're replacing this 1024 as 2 to the 10. Okay. And we know it's going to be a base 2, so if you don't know that, you probably don't know that 2 to the 10 is 1024, but what you would have done is we want to try and rewrite this so it's a base 2. So you would have tried like 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5 until you get the number you're looking for. So if 2 to the 10 equals 2 to the n minus 1, then 10 equals n minus 1, and you add 1 to both sides. So this means n is 11. So A1 is 3, A11 is 3072, our R is 2. And now we have all of the pieces that we need to substitute into the formula. So you need a to the 1, which was 3, and then our sum of the 11th term, 11 is what gets substituted in for n, and they simplify that down to get our formula. For B, it's the same process, but they've given you the information already. You don't need to write the formula. So this is the formula we want from the first term to the 20th term. So we're going to do, so when they say term 0, you're counting 0 and then 1, 2, 3, 4, all the way up to 20. So be careful with those. If it says 0 to 20, really you're looking for the 21st term. That's a little tricky there. A to the 1 is 4. 1 minus R is 1/2. And our n is 21. And then 1 minus 1/2. You get a sum of 8 for that one. You also, again, though, can use the calculator to calculate your summations for you. Just a reminder on that. All right, so using the geometric series formula, According to this story, a famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. So the soldier cleverly asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on for all 64 squares of the chessboard. So the king decides that that's reasonable because he hasn't actually done the math to figure out what that's going to accumulate to. So using the story, our first term, he first asks for just 1 kernel, and then he is going from 1 on the first, then 2, then 4, then 8, and so on. Okay, so we can find our common ratio. So 8 divided by 4 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2, so our common ratio is 2. And then we know that we're going up to 64 terms because he's going to do this on the 64 squares. So we have our formula here, substituting a 1 for the first term, a 64 for n, and a 2 for r, and you get 1.845 times 10 to the 19. So that's okay, quite a very, 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 very large number here. All right, next one, problem 3. So this gets into whether your sum, if you have infinite series, so the sequence just keeps going, if it's going to converge to a particular sum or if it's going to diverge, that would then mean that there is no sum. The rule that you use is if the absolute value of r is less than 1, then it's going to converge. And you will be able to use this formula, just on your formula sheet, to find the sum. If r is greater than 1, then it's going to diverge and there's going to be no sum. So for all these, you need to figure out what r is. So if it's a list, right, a sequence, you take the term and divide it by the one in front of it. If you're dealing with fractions, just make sure you put those in parentheses. So 1/2 divided by 1 is 0.5, which is the same thing as 1/2. So r equals 1/2. That is, in fact, less than 1, so it's going to converge. So here's your first term. That's what gets substituted for a1. And then it's 1 minus r, which is 1/2. Again, if you're not really comfortable with fractions and doing the math, you can have your calculator do it. Just make sure you put the parentheses in the proper places. So we have a sum of 2. For this one where they give you the equation, 2/3 is your first term, and then -5/4 is the r in this case. Again, just following the formula for an explicit formula for geometric series. Okay, that's how you know this is the first term and this is the r. -5/4 is greater than 1. You can, if you're not sure what 5/4 is compared to 1, you can convert it to a decimal. Okay, so absolute value of that is 1.25. That's greater than 1, so this one diverges. There's no sum. Okay, and some extra practice for you.